Okay, let us discuss the few problems. So this is 16.64. So something related to electrophilic aromatic substitution. 16.64. So what this problem says, if you have a benzene and you treat with H2O2 in the presence of acid, and in this case acid is CF3SO3H. So this is the acid, something like H2SO4. If you treat benzene with H2O2 in the presence of acid, it can finally be converted into phenol. Are you getting? So if you treat benzene with H2O2, CF3SO3H is basically acid, something like H2SO4. You have H2SO4 is this. So this is your H2SO4. And now only one thing, if you replace this OH with CF3, this becomes CF3SO3H. So you replace this OH, so remove this OH and put in this place OH, S double bond O and then put CF3. So this is something of H2SO4 derivative. This is even more acidic because fluorine will have minus I effect, so 3 minus I effect. So this is even a stronger acid than H2SO4. So it's a stronger acid. Are you getting or not? So in the first step, you see, if you see this reaction, what is happening on benzene, you are adding OH, and OH is what? It must be added as electrophile. So what the electrophile is? What is the electrophile? In this reaction, what is the electrophile? Can anybody tell me? OH plus. Good. So OH plus will be the electrophile. So I have electrophile is OH plus. OH plus is the electrophile. Are you getting? So OH plus is the electrophile. So we have, somehow I have to generate the electrophile OH plus, and that is my task. And if I able to generate this OH plus, rest of the things are easy. So simpler thing is you have to generate electrophile, and for that we have been given H2O2. So if you see the Lewis data structure of H2O2, so this is something like H2O2. Now from H2O2 you can generate OH plus, and one hint is also given to you, the medium is acidic, that is enough hint. If you taking the acidic medium and you have to break some bonds, you take all these into account, you can generate OH plus. Let us take 1 minute to write down the mechanism for this reaction. Okay, some of you might have done, no? So those who have not written, keep writing. So basically you have to generate OH plus. How will you generate? Any idea? Anybody is able to do or not? We have to break, let me give you another hint. You have to break OO bond, that is enough. Now I can do. Okay, let me do, those who are not able to do this one. So you have H2O2 and everything is there. And you have acid HOSO3CF3. So this is acting as a acid, this is acting as a base, so this takes H plus. This electron goes here, so this plus this you will have HOOH H plus. Are you getting? And now this will have SO3 minus. So let me make the condensed formula CF3. I'm not interested in this one. I'm interested in this one. Now you see I have to lose H2O. So if I want to lose H2O, I can flow the arrow something like this. and now I have generated the electrophile OH plus. So hydroxyl and I have generated the OH plus as the electrophile. Now things are very easy, simple. You have a benzene ring, you have electrophile, you can attack this electrophile OH plus. So you have the electrophile, benzene ring, and you have electrophile. So this electrophile can be added. First step will be loss of aromaticity, and the second step will be gain of aromaticity, that is the general step of electrophilic aromatic substitution. So I think all of you have able to understand this one. This is a fairly easy problem. If you have done this one, then we will go for the next problem. So pretty easy one. So you see, benzene, if treated with H2O2 in the presence of CF3SO3H, it can be converted into phenol. In this case, OH plus is the electrophile. So it can be used as a method to prepare the phenol. Phenol can be prepared using this method. Are you getting? Okay, let us discuss the next problem.